All right, so let's visually solve an equation. Okay, so we'll start with 5 minus 3 equals x. Now, to visually solve an equation, I'm going to have to graph. In other words, I'm going to have to go here. Right? I'm going to have to graph. Well, what do I graph and what does it look like? Well, let's look at this first. Okay, I'll get this out of the way. But let's look at this first one. If I'm going to graph these two expressions, I'm going to have to rewrite them in a specific form that I can type into Desmos. Okay, so well, what would that be? What we're going to say is this. We're going to assume that these two expressions have an output that is represented by the same variable. Again, these two expressions are going to have an output that are represented by the same variable. So we're assuming that the outputs should be identical. Well, what variable are we going to use to represent that output? Well, we're going to assume that the output equals y. Now, keeping that in mind, we're going to say, okay, if this is going to be our assumption and our kind of rule to help us visually solve this equation, then I'm going to start looking at the first expression. My first expression is 5 minus 3, and then the second expression is x, okay? So I'm going to erase that just so you don't get confused. So I'm going to start with y, my output, equals 5 minus 3. And that's my first actual equation I'm going to type into Desmos. Then the next one, and, would be this variable, x. So I'm going to have my output is equal to x. Notice that these two expressions have in common the same variable that represents their outputs. And that's their connection. Because they equal y, we can state that these two expressions are equal to each other. Solving algebraically in the previous video, solving graphically or visually by rewriting it as two separate equations, right? But they're connected. Again, they're connected by their output, y. So let's do the next one before we go into Desmos. Again, two expressions, when are they equal? I'm going to graph it. So I'm going to start with y equals, and I'll start with the first expression, 8. Done. And the next equation, y equals 2x, or 2 times x. Okay? We'll do the last one, the third one. 16x minus 16 equals 0. How's that going to work? The same way we did the other two. 16x minus 6, so I'm going to go y equals 16 times x minus 16. And the secondary equation, y equals 0. Okay? And so I'm going to graph each of these, and where they intersect should reflect when they are equal. Okay? Don't worry about, well, what if they're not equal? What's that going to look like? Don't worry about that right now. We're looking at if they're equal, when are they equal, and how does that reflect visually on my graph? By graphing it, then we're displaying how to solve our equation and what connects them, right? When are they equal? So let's jump into our graph. And where's my, there you are. There's a computer. And let's talk about graphing. Let's do the first one. The first one, if you remember back from the video, x equals 2. And so I graph y equals 5 minus 3. Look, it tells us the answer. And y equals x, right? And if I look at the graph, where do they intersect? At 2, 2. The input is 2, that's what x equals, and my output is 2. That's your final result. Notice that they have 2 in common, okay? Second one, we'll unclick that one. The equation was y equals x and y equals 2x. When are they equal? Well, graphically, these two equations, they intersect at the input of 4, output of 8. Therefore, x has to be 4, and both expressions are equal to 8, right? 8 equals 8. And if you look at the work you did algebraically from the previous video, your x equals 4 is your accurate answer, and that's how they're connected. So let's look at the final equation where we're comparing the two expressions. Y equals 16x minus 16 and y equals 0, right? And where do these two equations intersect? Right at this intersecting point. So what does x equal? Well, x is my input, that's 1, and my output is 0. So these two expressions equal 0, but the only value that works for them, that sets them equal to 0, is 1, and only 1. Okay? And that's how you visually solve an equation. And again, the connection is if they intersect, the first value of the coordinate point, which is your x value, is the same identical value as if you would have solved these two equations algebraically, where they're set equal to each other. X equals 1. Okay? Same thing about this one. You would explain if 2x is equal to 8, the only time they are ever equal to each other is when x equals 4. And for the last one, very simple. If 5 minus 3 is equal to x, the only time they are equal to each other is when my input is 2. And obviously my output is 2. Okay? And that is visually solving an equation. In the next video, we'll summarize everything that we've covered.